Hello students, let us solve a problem from NEET UG Paper 2021. Here is the problem. The problem states that the velocity of a small ball of mass capital M and density small d when dropped in a container filled with glycerin becomes constant after some time. If the density of the glycerin is small d by 2, then you have to find out the viscous force acting on the ball. So let us first understand the physics behind this problem. Then from there we will be able to find out the answer for the question. So let us suppose this is a container filled with glycerin and a ball is dropped. As soon as the ball is dropped, it will move downwards, and while moving downwards through the glycerin, there will be three forces acting on the ball. One is the weight of the ball itself, that will act in the downward direction, and there will be other two forces which are acting upward direction. One is U is the upward thrust, that is nothing but buoyancy force offered by the glycerin, and the other one is Fv, that is the viscous force which is offered by glycerin due to its viscosity. Now the ball will attain a constant velocity only when there is no force acting on the ball, and that condition will arrive only when the resultant of upward thrust and the viscous force becomes exactly equal to the weight of the ball. So from this condition we can find out viscous force if we know the upward thrust offered by the glycerin to the ball. Now let us find out the value of this U, upward thrust. Before that, let us see what are the informations available in the problem. The mass density of glycerin, let us say that is sigma, and that is given by small d by 2. Mass density of the ball, let us say that is rho, that is given by small d, and suppose the volume of the ball is capital V, and hence the mass of the ball is capital M is equal to rho into V. Now what is upward thrust? Actually upward thrust will be the weight of the displaced glycerin, or the glycerin displaced by the ball. So that is, suppose M prime into G, that is the weight of the displaced glycerin. So how to find out M prime? M prime is sigma into V. V is the volume of the ball, and the ball will actually displace the glycerin by this much volume itself, the volume of the ball itself. So M prime is sigma, that is the density of the glycerin, and V is the volume displaced by the ball, volume of the glycerin displaced by the ball, and hence sigma into V into G will give you M prime G, which is the weight of the displaced glycerin. Since this V, capital V, is not given, we will replace this from this equation, writing capital M by rho. If we put that value of V as M by rho, then we get M prime G, that is the upward thrust, as sigma by rho into M into G. Therefore the viscous force can be written as mg minus M prime G. This is nothing but the effective weight of the ball. So if we put the value of M prime G, we get mg whole into 1 minus sigma by rho. Now sigma is d by 2 and rho is small d. So upon simplification we get the viscous force Fv is equal to half into mg. Therefore the first option would be the correct answer for this problem. Thank you.